Hello and welcome to Chapter 2, Section 4. Today we're going to be solving equations with variables on both sides. So we're taking our multi-step equations and we're making them just a little more complicated. And we're just going to start right out with how the heck do you do this? I've got a 7K and a 4K in my equation and a number. I want to get all of my variables on one side and all of my numbers on the other side. And it's easiest if you get the variables on the side where they'll end up positive. If I said -7 here and -7 here, I would end up with -3K. I'd rather have positive K's if I can, if it's the easy way. So I'm going to subtract 4K from both sides here. And this is going to go away, and I end up with 3K equals 15, and now it's easy to solve. And K equals 5. What if I have numbers and variables on both sides? I'm going to get all of my variables on one side and all of my numbers on the other side. And I'm going to do the variables so that the variable ends up positive. So I'm going to bring my 3x over to this side so that that gets this gone, which means I need to get rid of the numbers here. So I'm going to get rid of these numbers here. And that's gone. So now I have 2x equals 6, and I can easily solve for x now. What if we have a distribution issue? First thing I'm going to do is distribute. 2 times y is 2y, 2 times 6 is plus 12, equals 3y. I'm going to get all of my y's on one side, minus 2y, and that's going to give me 12 equals y. Let's do that again, a little more complicated. Here I've got a distribution problem with even more on the other side. So I'm going to bring my first half down. 3 times 1 is 3, and 3 times -2k is -6k. So now I've got variables and I've got numbers, and I need to get all the variables on one side, preferably a positive side. So I'm going to add 6k to both sides. And that's going to get rid of this. So now I need to make sure I get my numbers to this side. So I'm going to add 5 to each side this way. So those are gone. So now I have 8k equals 8, which means k equals 1. Check this guy out. Let's see how complicated we can make this. So I see that I've got a distribution problem. -2 times 1 is -2. -2 times -b is positive 2b. And I'm going to bring everything else down. I have these two that I can combine. Let's do that to make this as easy as possible. -5b plus 2b is -3b. Let's combine our numbers here as well. -2 and -2 is -4 plus 2b. So now I've got it so that I can easily just flip-flop them. I'm going to make my b's go on the positive side. So I'm going to add 3b to both sides. So this goes away. And I want all my numbers on this side. So I'm going to add 4 to this side. So that goes away. And I end up with 7 equals 5b, which means b equals 7/5. You now have everything that you need to try. Check it out, numbers 1 and 2. Pause the video, come back when you're done. Check it out, number 1. I chose to send 4b to this side just to show you what you do with negative variables. So that gives me 2 equals -b or -1b. And I'm going to divide each side by -1, and I end up with -2 equals b. If you did it the other way and you did 4b plus 2 equals 3b, and you went negative 3b and negative 3b, you ended up with b plus 2 equals 0. And you might have gone, what do I do now? You can subtract 2 from both sides, end up with b equals negative 2, and we get the same answer. So I chose this way because I only have a number on this side, so I took the variable to the other side, but you can do it this way as well. And then you don't have a negative variable to deal with. Up to you. This one, I chose to send 3y to this side, so I sent 0.3 to this side, and I ended up with 0.8 equals 0.4y, and when I divided, I ended up with y equals 2. Check it out, number 2, I distributed my 1/2 to both of the terms in the parentheses. 1/2 b plus 3 equals 3/2 b minus 1. I subtracted the 1/2 b to this side. I added the 1 to this side. I ended up with 4b. Here I distribute my 2 to both the x and the 2, and then I combine these two terms into a positive 6. So I'm going to take the 2x this side, and I'm going to take the 6 to that side, and I end up with x equals negative 2. Remember, because you have parentheses, you're going to distribute first, then you're going to combine like terms, then you're going to get all your variables on one side and all the numbers on the other side. Then there are some problems in which you get identity. And with identity, this means the equation is always true no matter what the x equals. What this means is that all your x's are going to cancel out. Now, the flip side of that is that sometimes some equations that you get are always false. And this is going to tell you something like 2 equals 3 as your answer. And you know 2 doesn't equal 3, which means either you made a mistake or you have an equation that's always false. So let's practice with some of those. X plus 4 minus 6x equals 6 minus 5x minus 2. So here, I'm going to start by combining my like terms. X minus 6x is negative 5x, and I've got a 4. 6 minus 2 is 4 minus 5x. So you see here, I can already tell you that if I add 5x to both sides, and I subtract 4 from both sides, I'm going to get 0. Which means that any number I stick in here for x will always work because these two things are completely equal. Negative 8x plus 6 plus 9x equals negative 17 plus x. So here I'm going to combine my two like terms, negative 8x plus 9x. That's going to give me x plus 6 equals negative 17 plus x. I'm going to subtract x from both sides, and I end up with 6 equals negative 17. And it doesn't, which means this equation is false. And then on to our word problem. Long distance phone companies are shown in the table. How long is a call that costs the same amount no matter which company is used? So we have 36 cents plus 3 times the number of minutes that we call. When is that equal to 6 cents per minute? So we have to solve for the number of minutes it takes for both of these to be the same. So I'm going to subtract 3m from both sides, and I end up with 36 equals 3 minutes, and at 12 minutes, both these plans equal the same thing. If you could do check it out numbers 3 and 4 on page 102, push pause and come back when you're done. Check it out number 3. I combine 4y minus y to get 3y plus 7 equals 10 plus 3y. I subtract 3y from both sides and I get 7 equals 10, and that is not true. So I draw that slash through the equal sign. Here I combine 2c plus c to get 3c, and I bring down my 7. And my 3c, I combine 14 and 21, and I get 35. I subtract 3c from both sides, and I get 7 equals 35, and that is not true. So both of the check it out samples show you when it's not true, and I did want you to see just one more, what it looks like. I pulled number 10 off of the page 103, just so you can see what another identity problem looks like. So here I combined negative 2x and 9x, and then I combined 1 and negative 5, so I end up with 7x minus 4 equals 7x minus 4. So here's another identity problem. And then we have number 4, check it out. 4 times Greg's age decreased by 3 is equal to 3 times Greg's age increased by 7. How old is Greg? So I'm going to subtract 3g from both sides, and then I'm going to add 3 to both sides to get g on this side and 10 years old on that side. And that's all we have for Chapter 2, Section 4. Your homework for tomorrow is page 103, numbers 15 to 33b, plus number 54. See you tomorrow.